Okay, in this video, we're going to work on simplifying rational functions. We're going to start with some that look like monomials over monomials, so let's just write out some of that stuff. Okay, so a monomial, remember, it's just one term of a polynomial, basically. It's a one-term polynomial. So you've got variables multiplied together, and maybe there's a number attached to it. So, for example, we might have something like 2m squared n cubed over 3 m n to the fourth. And so this is a rational expression because I've got variables, I've got numbers, and I've got division, right? I've got division of polynomials. A monomial on top's a one-term polynomial, one-term polynomial. Okay, so what we have to do is we have to basically cancel out anything that can cancel. Just like if you were going to simplify 4/8, right? You would cancel the 4 on the top and the bottom, and you get 1/2. Okay, same idea here. The 2/3 is already in lowest terms, so that's good. So we'll keep the 2/3. I've got an m squared on top and an m on the bottom, so I can cancel one of those m's. I'll be left with an m on the top. I've got 3 n's on the top and 4 n's on the bottom. 3 of them are going to cancel. I'll be left with 1 on the bottom, right? So I'll have 2m over 3n will be the simplified version of that. Okay. So let's do one that's basically the same idea, only we don't have just m's and n's. So let's look at 4, and I've got x plus 1 squared, x minus 3, and let's do 12 x minus 1, x plus 1, x minus 3 cubed. I still have the same ideas. I can still cancel stuff top and bottom. I can simplify the numbers, right? I've got a 4 on the top, I've got a 4 on the bottom, so that turns into 1/3, right? That fraction. I don't necessarily need the 1 on top, but I'll write it there for now. And then when we sort of clean things up at the end and write our answer, we'll probably get rid of that. I've got an x plus 1 squared on top, so I've got 2 x plus 1s. I've got 1 x plus 1 on the bottom, right? So I've got 2 of them up here and 1 on the bottom. One of those is going to cancel top bottom, so I'll just be left with 1 on the top. So I'll have an x plus 1 just to the first, and remember we don't write exponents of 1 up top. I've got an x minus 3 on top. I've got 3 of them on the bottom. Okay, so 2 of them are going to be left on the bottom. I still got this x minus 1 hanging around, so I'm going to put that in first just because in the problem it shows up first. And then this and these guys are going to leave me with an x minus 3 squared down there, right? There was 3 of them. 1 of them canceled, so there's only 2 left. So this simplifies. I'm left with x plus 1 on top, 3 x minus 1, x minus 3 squared on the bottom. And that's the simplified form of that. Okay, so monomials, everything's multiplied together. There's no addition. There's no factoring that needs to be done before you cancel, right? When you have fractions, you cancel multiplication with division. So if all we have here basically is a bunch of stuff in parentheses multiplied together, then I'm dealing with multiplication and division. When you don't have just multiplication, right, you have an actual sort of expanded polynomial on top. Let's look at a form like that. Oops, simplify. Okay, if I have something like x squared plus 2x plus 1 divided by x squared minus x minus let's say 2. So right now I've got the division, but I don't have anything multiplied on top or multiplied on bottom. I've got these additions and I've got the subtractions. So it's not in the form where you have a bunch of stuff multiplied together and then divided. So we have to put it into the form where we can actually cancel, because division cancels multiplication. I don't have any multiplication up top. It's just one thing right now. I could sort of put in a hidden parentheses, and I'd have to do all of that stuff first before I would divide by all of this stuff, right? Okay, so let's factor it out, and then we can see that there's actually multiplication happening. I've got this x plus 1 squared, right? If I factor out x squared plus 2x plus 1, I get x plus 1 squared. And on the bottom, this looks like it's going to be x minus 2 times an x plus 1. Okay, so this, after we factored it out now, I've got multiplication on top. I've got x plus 1 times x plus 1. I've got multiplication on bottom. I've got x minus 2 times x plus 1. And then I've got the division between them. So now I could actually do cancellation stuff, right? Division cancels multiplication, so I can cancel the x plus 1 with one of the x plus 1s here, right? This guy can cancel. I'll just be left with 1 on top. So this is going to be x plus 1 divided by x minus 2. Put those parentheses in there. I don't actually need them, but that simplifies as that. Okay, let me show you one of the common mistakes that you do not want to make, right? So this x squared plus 2x plus 1 divided by x squared minus x minus 2. Okay, I'm going to do this in red, if I can find the color red. Yeah, because this is something that you do not want to do. Don't do this. Okay, you see an x squared here and you see an x squared here. You can't cancel them. Don't do that. This x squared is not being multiplied by all of this stuff, right? This is not a multiplication. It's an addition. This is not a multiplication. It's an addition. So this division sign, you can't cancel these x squareds because this x squared is not multiplied by all this stuff. This x squared is not multiplied by this stuff. So don't cancel addition with division. Just don't do it, right? This is bad, okay? That's a common mistake. You see a lot in algebra, but don't do it. You have to break it down so that you've got multiplication stuff going on, okay? As soon as you find that multiplication stuff, you can cancel multiplication with division. All right. That's that for that video. This video. We'll do a little bit more in the next video.